The next section here is access control. There are 3 different approaches to access control, and you'll need to know each of these methods, what they do, and when you would want to choose those. The first one is mandatory access control. You'll see this abbreviated as MAC. Obviously, we have that acronym used elsewhere for media access control. In terms of security, this is actually one way that you can set up access models. When you're working with mandatory access controls, I think the key to this particular scheme is making sure that every piece of information, every piece of data that you're trying to secure has some sort of an identifier, some sort of a label that tells you how critical that data is. And pretty much you categorize things, and then based on that level of security clearance, different people can have access to that. The hallmark, though, of mandatory access control is identifying a security level and labeling that, and then you're working continually off of those labels. Discretionary access control is kind of at the opposite end of the spectrum. With discretionary access control, the user has complete control over that. They can set up access to other users. Let's say I'm in charge of a database and I have the authority to add users and to say they can have read or write access, or I can also possibly have enough authority so that I can assign change permissions, delete permissions. Usually if you're going to set up discretionary access control, you need to make sure your users have training and know what the risks are. Role-based access control is pretty much what it implies. If you need to run backups, there is a certain set of permissions that you need, and those permissions are defined instead of a user having those defined on an individual basis. You end up assigning permissions of that role to a given user. And this is actually a pretty standard implementation. When you set up groups, your accounting group has access to the accounting folders. Your salespeople have access to sales data, and they don't cross in there. So when you talk about role-based access control methods, and this is commonly referred to as MAC, DAC, and RBAC. When you think about role-based access, think about it in terms of groups. And if you set access control based on groups, that's very similar to what you're doing with the role-based access method. The next section the book talks about is authentication. And authentication is proving that a user is who they say they are. Authentication can be as simple as a username password. That's a pretty standard method of authentication. However, it's pretty easy to compromise. Most of the time you can guess somebody's username. If they happen to leave their password on a post-it that's right next to their monitor, it's not too hard to access the network using somebody else's credentials. If you need more security, then sometimes what you are authenticated on is what you know, the username and password, plus something that you possess. That something that you possess could be a smart card, it could be some sort of an ID device, a key that you have to have. That adds another layer of complexity. Another layer of authentication can be something that is unique to an individual. You could have thumbprints, you can have palm prints, you can do voice recognition, you can do retinal scans. I'm sure all of you are familiar with the very first episode of 24, in which Jack Bauer needed somebody's thumbprint to get in somewhere, and so he cut off the dude's thumb and put it up and went in and saved the day. Most biometric methods right now will register the fingerprint, but they will also register the temperature. And so if it's not at body temperature, at this point Jack Bauer probably could not get away with the cutting off the thumb thing. Another form of authentication is a certificate, and these are generated by computer. Depending on your application, you will hand those out to remote users. They will install them into their browser normally, and then you present that certificate as part of your authentication. Moving on, the next section is the Challenge Handshake Authentication Protocol, also known as CHAP. When you use a challenge protocol, you're not necessarily using a username and password. Those may be components of that, but those are not the elements that are transmitted. Very often when you're using CHAP, you type in a username and password. Software on the client side is going to take that information, run it through some sort of an algorithm, encrypt it, send it across the wire to the receiving end, and then they will take that information and generate their own set of algorithms and compare what was sent. Then they'll take some output from that and send it back. So So you're not actually sending those credentials back and forth, but you are using them as part of the process. Another method of authentication is Kerberos, and that is the default mechanism that we use in Server 2008, Server 2003, even Server 2000. And if you look in the book, it tells you that that was the mythical three-headed dog that stood at the gates of Hades. I think the deal with this is it's a metaphor for this is going to be hard to get through. If y'all watch the Harry Potter movies, I forget which movie it was, but they had a three-headed dog, and that was ostensibly a takeoff on Kerberos. So Kerberos is pretty popular, and it uses something called keys. Those keys are managed by a key distribution center, or a KDC. And so when you're taking any certification exam, Kerberos starts with a K, key authentication center or key distribution center starts with a K. So a lot of times you can kind of match those up. Not that I'm giving away answers to my tests, but when you take the certification exams, that could be something that helps you. Multi-factor authentication is nothing more than taking a couple or more of these and combining them. Combining a smart card with Kerberos and a retinal scan, or having a couple different layers of password authentication. It's just another way of kind of ratcheting up your level of security. Security tokens are similar to certificates. The token is something that is generated when you first sign on, and then that token is compared to anything that you try to access. Some operating systems will generate that token and then use that whenever you try to access a resource. If elements of your token are in the access control list, then you're able to go. If it doesn't match, then your access is denied. The next section, authentication issues to consider. You've always got this balance between making things complex and then making it so complex that people are going to write down their passwords or put it on a post-it. So it ends up being self-defeating if you get it too tricky. I thought it was interesting that in the book they talk about the first release of Star Wars, which was in 1977, I believe, because I went and saw it. It said two of the most popular passwords back then were C3PO and R2D2. The next section of the book talks about security topologies, and I know that you've covered network topologies in your networking classes. The networking topologies deal with how things are interconnected. Are you in a star? Are you in a ring? And God forbid if you're on a coax connection where one break in there pretty much makes sure that everybody can't connect. Security topologies don't really have anything to do with the physical layout. Instead, they mostly deal with design and implementation. The text takes you through some of the thought processes behind this approach. When you're setting design goals, generally what you're going to try and do is, again, categorize your data. Some of it you need to make sure is confidential. This is generally going to be proprietary things or financial things that you don't want out. Some of your data is not going to be confidential, things that you post on a public website, user manuals or parts numbers. You're not really going to care about confidentiality there. So you will have to categorize your data. But essentially, confidentiality means that you are restricting access and that only people who need to see this information actually get to see it. The next component that you need to worry about is integrity. What you're doing with integrity checks is making sure that the data has not changed. When you're transmitting information, pretty much you're sending ones and zeros. Those get transposed. That could be a pretty big deal. And so integrity just makes sure, like with cyclic redundancy checks or error correction, that you don't have any bit flips going on. Availability is making sure that the data is present when it needs to be. If you are doing real-time reservations, you need to make sure that your flight schedules and your credit card processing is up and working. If people are trying to make reservations and they can't get their credit cards to be authorized and they can't pay for their trips, they're going to go somewhere else. In terms of availability, a lot of that has to do with what's your business purpose, what sort of activities do you have, and then classifying those as critical. They have to be up, or we can do without them for maybe 15 minutes. And a lot of those time constraints will dictate what you're going to have in place in terms of business continuity plans, in terms of extra hardware, in terms of people being available for on-site troubleshooting. troubleshooting. There is a section in here on computer availability, and I think it's very interesting. If you look at 99% uptime, for 98% uptime, it says that you're down for 7 1/3 days. Maybe that's okay if you do 9 to 5 and you happen to have all of your days when things are down or on the weekends. Usually that's not the case. And usually you want to be in the 99 point range. That's generally what's acceptable to most people.